Scaling a landscape for Unity in Blender using imported Unity assets and Blender GIS maps exported as .fbx files for ultimate inclusion in our Spatial.io Florida Wildlife Corridor curriculum project. Let's pick up where we left off in the last tutorial. Let's explore creating the landscape in Skybox using the FBX export option I mentioned rather than using the .blend file. This is important if you want to build a world using off-the-shelf landscapes and Skyboxes you get from Sketchfab or other websites. First, let's create a new scene in the same Unity project so we can compare them and get familiar with what a scene is. When you click on New Scene, you'll still have access to all the assets you imported, the files and animals and vehicles and such, but you'll have a new playground in the same project to play with them in. I tend to make each scene a basic scene with a built-in camera and light and horizon to make it easier to see. Otherwise, in an empty scene, you'll have to bring in lights and cameras. I do a save scene as and give it a name, Rosebud FBX scene, for example, and it's now ready to bring my FBX environment and Skybox in from Blender or anywhere else. Go back to Blender and select the sphere and go to Export as FBX this time. We'll start with the Skybox sphere. Make sure that you have flipped the normals so that the sphere appears red from the outside and blue from the inside when viewed with face orientation enabled. It will either appear red from the outside or blue. Usually when you bring in a sphere, the program default is you want it textured from the outside, so it'll appear blue outside and red, no texture inside. You do that, for example, to make a model of the Earth viewed from space. But here we want to view the sky from inside the Earth, so you want it to be red on the outside and blue on the inside. You can go inside the sphere to check if it's red or blue from the inside. If it's red, then the image isn't going to show up on that side when we bring it into Unity. So go to Edit and Mesh and Normals and flip Normals to make it blue. Only blue surfaces show images in Unity. In Blender, both sides show images, so don't be fooled. Now you can export it to Unity. To successfully export an FBX with its materials so it can be used in Unity, you must select only the individual object you want to bring in, and you must check Include Limit to Selected Objects. And now this is critical. To get the materials to work with it, to make the textures work, you must make sure that the path mode is set to copy and that you check and highlight the icon to the right of it, the one that looks like the typical copy picture, so it turns bluish. Now let's bring it into Unity. Drag it into the Assets folder, and then from there drag it into the hierarchy, not into the Scene window, so it'll be positioned at the center of the world. That's how things line up. And when we zoom into the inside of the sphere, we see that our normals are correct. The texture of the skybox appears from the inside. Now we can go ahead and add the bus and animals for sizing like we did in the other scene when we used the Blender file. Or, and let's check this out this time, we can add a vehicle in Blender and get our size right there before we send out the FBX. But to do that, we'll need to have a Unity vehicle or person or animal handy that we can bring into Blender for sizing. This will show you that we can work both ways with Unity and Blender. So, let's bring in our third-person robot controller figure that we used before, a much lower polygon count than the school bus. However, we don't want to bring in the complex animated prefab. It will cause all sorts of grief in the exporting process. Now, all we want is a simple person mesh sized appropriately for Unity worlds. So let's bring in the simplest mesh in the character folder. Of course, it comes in huge, as we would expect, because our landscape and skybox were so small. Now, rather than sizing the world in Unity, let's export that figure to Blender and do the sizing there. To do that, we need to install and enable the FBX exporter package that comes with Unity in the Package Manager Unity registry, but is normally hidden. This tool is so darn useful for modifying Unity assets to customize them in Blender. For example, what if I really want to make the supplied brown bear black? While retaining the Unity functionality, they really should make it a default feature. Once installed, which only takes a minute, when I select the object and go to Game Object, you can see the option Export to FBX now appears. Now you have to delete the armature and all the other meshes but one. I use the LOD 0. Make sure you've selected the prefab that contains the mesh. You should see a blue-gray line around the mesh, not a green line or capsule or bounding box or an orange line. Pick a destination. I put it in my 3D Objects folder for FWC animals, and make sure you use the binary export format, not the ASCII that is the default, and models only, not animation, and hit export. Now we open our Blender file again and import the robot model. Now you have a figure you can always use in Blender to size things. You can scale up the world in the skybox using S to make it match the figure we just brought in. There, that's pretty good. Now there's another technique that we suggest for scaling, and that is to always have a Unity car available too, since a lot of times you can match a car model to an aerial image of a car picked up by photogrammetry. In my assets in the package manager, I have some low poly cars I downloaded for free back in 2020, so I can import those into the project. To use the same procedure, if the model has no armature, animations, or levels of detail, LODs, you don't have to delete anything, just select and export as a binary. Then import in Blender as an FBX and boom. As you can see, it comes in appropriately sized and gives us more cues for appropriately scaling our photogrammetric scan of the area. Now there's one more element we can bring into Blender for both accurate scaling of the photogrammetry and to give us a larger environment to move around in Unity and ultimately spatial. The Blender GIS topography of our area, which we looked at in the last tutorial. You know how to bring this in. Go back to the previous tutorial if you don't have Blender GIS installed. You simply launch Blender GIS and now hit G to go to the right map and put in the address and size and scroll into the area we want to capture and then hit E for the extent. Great. Now let's get the elevation. And now let's go for possible buildings. Okay. Now let's see how that plane can be used with the photogrammetry model and the skybox. To find objects in Blender 4.0, because they will not necessarily match the position of the Blender GIS map, you can select them in the hierarchy and then hit the tilde key on the top left of your keyboard and then choose View Selected, and it will zoom in on those selected objects and then you can move them where you want. Now, when we put the photogrammetry mesh on top of the right location in the Blender GIS plane and rotate it properly, we see it can now be appropriately scaled to GIS measurements, which of course work with our car and person that we got from Unity. Because these objects are scaled to real-world coordinate sizes. You can also see now how the car we brought in matches to the Blender GIS map if we move it over onto the street, indicating that this is indeed all to scale. Now let's bring the skybox back in place. And now we can export each element to an FBX that we can bring into Unity. We'll start with the GIS landscape and make it our baseline FBX for our world. That'll be our walking plane. Then let's export the now perfectly matched, that is, matched to the GIS map photogrammetry mesh. And finally, export the now appropriately sized photosphere. Bring all three FBX files into Unity. Let's first delete the old Skybox and Environment Mesh FBX files because we won't need them again. Keep the car. Now, when we drag in the GIS map, notice, of course, it has no texture. For that, we need to save the materials texture image from Blender UV mapping and import that into Unity too. Okay, now we drag it on. And voila, we're ready to bring in our vehicles and animals and other objects. When we hit play, the animals start moving and we know we've successfully created a world. Now the trick is to get this world into Spatial, and we'll turn our attention to that next. Special tip for developing in Unity. If you want to follow your InVector third-person controller avatar around your world, you simply drag the provided V third-person camera into the scene and turn off the main camera, and then hit play. So here I am turning off the main camera by unchecking it over here. And now we simply hit play. You can see you can move the camera around, and then you can see in the bottom right what it sees, but because the script is tied to the third-person controller, it doesn't really matter how you position that camera because it's going to follow your character. Now, as we hit the WASD keys, we can move that character around and the camera follows the character. And as we move our mouse, we can hit the space bar and make it jump, and this gives us an ability to explore our world in Unity and see where any problems are before we start building for Spatial, which is what we're going to do in the next tutorial. One thing to check is if we added collision properly on the GIS map, and I don't recall doing it, and that's the proof. We fall right through it. So we did have collision on the photogrammetry mesh, but we don't have it on the GIS map. So you're going to have to put that collision on by clicking on the GIS map landscape, add component, and then go to a mesh collider. And now when you hit play, let's save it first. Now when you hit play and give it its chance to compile, so we're all okay. So there's that wacky bear animation that we're going to deal with in the next tutorial. That's part of a sequence of animations from the animal pack that we brought in, and they have the bear falling dead, which is kind of comic. So now, as you can see, we're on the GIS map and we are not falling through anymore. So we have all this real estate that we can develop that is tied to the actual spatial location that we pulled in off of Blender GIS from the world map. And that lets us accurately put in trees and solar panels. You can see I'm walking over right now, and put in roads, and then we can make the modifications that we want to in order to make it a more wildlife-friendly environment. And then when you reach the edge of the world, you do a Christopher Columbus, and that is the end of your game. So thanks for watching. In the next tutorial, as I've mentioned, we will get to how you put all this into Spatial. So bye for now.